Okay, picking up where we left off on page 353, we're talking about some terms associated with the database management system components. And the next one on the list is what the physical data repository. So you don't necessarily know exactly how the tables are laid out or how they're put together. And that's okay, because you don't need to know those kind of details. You just need to know that the tables exist and somehow they're magically combined together. But there could be some, if you're a database person, you need to know exactly how the fields are put together and how the relationships, anyway, all using a schema. So that physical data repository is usually defined by the schema. Okay, on page 354, they talk about web-based use of databases. One of the cool things about the web is I don't have to have practically anything installed on my system to be able to use a database. For example, if I wanted to connect my PC, I wanted to connect directly to an Oracle database, I would probably have to have some Oracle client software installed on my machine, wouldn't I? Yeah. How about SQL Server? Would I have to have something installed on my machine? Yeah. How about MySQL? Would I have to have something installed on my machine? Yeah. But if I put it on a web server, the database is talking to the web server, and then my client PC, is talking to the web server, and I don't have to have anything installed on my machine other than a browser, because I am not directly talking to the database. So the web is acting as an intermediary between me and the database, and therefore they can have any software package they want, because they only have to install the client one time, and that's on the web server. So it could be some strange oddball software that you've never heard of before, and you don't have to go dig around and find some client software that matches because the web database has it. So here's some advantages. This is kind of generic. A lot of these things apply to web technologies in a general sense and not necessarily specific to database, but let's just go through it. So, global access, put it on the web and everything's got it. Ease of use, all I have to have is a browser. Multiple platforms. I could be running on a Mac. I could be running on an Android device. I could have an iPad. And all these systems all work because the web standards, in theory, provide that cross-platform capability. Cost effective. I put in one database, I install it, I tune it, I hook it up to a database, and I'm kind of sort of done. I don't have to go around to all these places and install multiple copies of databases and all those kinds of things. Security issues. Well, okay, the web is a bit fraught with problems with regard to security, but in the context of a database, I can, if I had 15 copies of my database scattered across the U.S., I'd be a little nervous about, do they have the proper controls on the database in Seattle, those kind of things. But if I had a web server, I have complete control over this thing, and I know exactly what security measures are in place, and I feel a little bit more comfortable. And then, of course, this flexibility and adaptability. Ease of access, flexibility. I should be able to pull data the way I want it, those kinds of things. I can add additional software onto my machine if I wanted to provide me additional capabilities. Those kind of examples. Okay, so on page 356, you talk about some additional terms that you need to know. And yeah, unfortunately, you need to know these terms. The first one is entity. Now, we've used entity before, and it's extraordinarily simple, similar to what we've talked about before. An entity is a person, place, or thing, but in this particular context, it's a person, place, or thing related to the database. Come on, that's what this chapter is all about. So these things have attributes, and attributes are typically going to be the fields associated with this table. Almost always, not always, but it's likely that an entity will end up being a table or a series of tables. Okay, so an entity is a table. Now, in the database world, you'll see people talking about tables and files as if they were synonymous. Now, just a few minutes ago, we talked about the difference between using table-based technology and database-related technology. That is not what we're talking about. And again, once again, they're using these terms in different contexts. The table here and the file here are historic. So I say table, I rarely ever say file, but some textbooks use that file as the next hierarchy. You have a database. Underneath the database you have a file. Underneath the file you have a record. Underneath the record you have a particular field. So this little pyramid shaped thing. So once again, let's go through that a little slower this time. So you have a table or a file, and inside that you have a record. Now this, again, terminology, you could call it a row. Now I often use the word row. So a record or a row or a tuple. Now if you were getting a degree in database design, you'd probably be talking about tuples. But come on. In the common vernacular, record or row works just fine. The next one is the field, individual fields in a record, which you could say column, you could say attribute, you could say field. So these are the individual things that actually contains the data. Okay, on page 357 they talk about some keys. And there's a thing called a primary key and a candidate key and a foreign key and blah, 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 blah. I'm not going to go through all of that because, quite frankly, what they're called and what they do isn't near as important as just understanding what they do in the big sense. So, boy, if that don't sound like a test question to you, I don't know what. I'm going to ask you something about, what's the fundamental purpose of a primary key? And the answer would be, primary keys uniquely identify a row. That's it. That's all it is. I mean, you can take all that text, an entire paragraph, and pages and pages and pages of stuff. It all boils down to the purpose for a primary key is to uniquely identify a row. Simple. A foreign key. The purpose for a foreign key is so that I can relate one table to another. Likely having one field in one row connect to one or more fields in another table. I'm sorry, one or more rows in another table. So a foreign key is designed for linking tables together. That's it. So woohoo! We condensed 2.5 pages of text in our book to 2 sentences. Yay! The next one on page 359, they talk about the referential integrity. And that's a cool term, and you probably should understand what that term means. Basically what it means is I've set the constraints in my database so that, let's say that something has to exist prior to something happening. It's a horrible explanation, but let me give you an example. Let's say that you're a student in a college, and you're creating a new record, and when it comes to the field that says your advisor, your graduate advisor, and you put Bob in there, it can come back and say, I'm sorry, Bob has to already exist in some table of student advisors, and if it doesn't exist, well then you can't use Bob. That's referential integrity. That I cannot refer to a related related table unless that thing already exists. Now, you might think, well, that makes sense, yeah. Well, here's a bizarre scenario that comes up whenever you're building a database at the very beginning. So let's say that I've just built this database, I turned on all the referential integrity, and it's time for me to start adding data. So I say, well, let's say I'm converting it from an older system. So I say, okay, let me grab the student table and I, do like a copy. Then I go to my database and hit paste, and it goes, nah, you can't enter this because you don't have the student advisor table. And you go, oh, okay. So let me go get the student advisor table, and I go pop it in there, and it goes, nah, can't do that until you got the employee table built. And you go, okay. And so you go get the employee table, and you finally. So the point is, when you have referential integrity turned on in a mature database, it's operating, it works magnificently. When you're creating a database from scratch and you have no rows at all in your database, referential integrity can be a royal pain in the butt just for that one time. because you have to insert things in the correct order. Now, I will confess that sometimes I get frustrated and I will temporarily turn off referential integrity, dump the data in the order that I want to dump it in, and then after it's there, I turn referential integrity back on. So it's like, all right, from now on, I'm going to make sure things are done in the right order, but not at the very beginning. Okay, just an interesting story about how referential integrity helps you in a mature database and can be rather annoying when you're trying to create one from scratch. Okay, on page 360, they talk about an entity relationship diagram, an ERD. And this looks probably very familiar with that data flow diagram kind of a scenario. These have a little bit more detail, and they're designed for database people. Database people can take an entity relationship diagram and kind of use it to figure out what's going on. Now, the reverse is true. You could go into SQL Server, as an example, of let's say you inherited, this is your first day on the job, and you inherited a database in SQL Server, and you go, man, I don't have a clue how this thing's put together. You can actually go in there, and there's a little thing under the databases called diagrams, and you can hit that and says, build me a diagram, and you light up all the tables and say, draw me an entity relationship diagram, and boom, it'll actually produce a diagram. Now, it's not technically an entity relationship diagram, but for all intents and purposes, it serves the same goals. So the entity relationship diagram is a really cool diagram that kind of shows you how everything is all related. Entity relationship diagram. Now, I am not going to cover this in detail, and I'm not going to ask you to do this in homework, and I'm not going to have you draw an ERD for the test. So I'm going to skip over some of the drawing parts. Please do read the entire chapter, but I'm going to skip down to page 362 where we talk about cardinality. Now, once again, cardinality is one of those 10-cent words that basically means how a relationship between two parts, that for one of these I can only have one of these, or from one of these I can have more than one of those. So cardinality is the thing I just mentioned about, for every student, I probably will have more than one course. So a student can have multiple courses in a semester. Makes sense? Could I say that for every course I have to have one or more students? Probably. That makes sense. I mean, if you had 0 students, you probably would cancel the course. So there's some relationships there about one-to-one. For every student, I must have a student ID, and for every ID, I must have a student. A one-to-one relationship. Those kinds of things. So there's some cool little diagrams. They talk about the crow's foot format, but again, I want you to know what cardinality is about. I don't want you to have to draw it, but I do want you to be able to explain it on a test. Explain what cardinality is and why it's even relevant. Why do I need to know if it's a one-to-one relationship or a one-to-many relationship? What difference does that make? So if you can answer that question, then you'll do okay. So let's skip to page 395, talking about normalization. And this is where the book kind of goes off on the deep end big time with regard to getting into the weeds on what normalization is all about. Now, I confess, if this was a CIS401 course on database design, we would spend 2 or 3 weeks on data normalization. It is an important term, an important concept, and it deserves some attention. However, in this particular course, I'm going to hit the highlights and try to get you to be able to explain what data normalization is all about. Not to be able to apply it, but just explain why it's important. Okay, we're coming up to the 15-minute mark, so this is probably a good place to stop. See you again in just a few.